Hi guys, good evening.
Good evening, sir.
Can you hear me?
Good evening, sir.
Yes, sir.
Yes.
Yes, sir, we can hear you.
Anyone? Yes. If anyone unable to hear me. Anyone unable to hear me? Rejoin the session. Yes, rejoin into session. Rejoin into session. Yes, anyone unable to hear me, just rejoin into session. Simple solution, rejoining. Yeah, so let us start session. Today's session. Yes. So previous class, see yesterday's class. 1 second. So yesterday's session. Yes. 7:30 p.m. Yes, day 4. Day 4 discussed about interpreter and compiler, right? About interpreter and compiler discussed. About interpreter and compiler. Yes, about interpreter and compiler. Yes, these introductions. Yes, all these introductions discussed. Yeah, Monica, please rejoin. Yes, Monica. Monica has to rejoin. Has to rejoin. Yes, you are in offline. Has to rejoin. Yes, has to rejoin. Please rejoin. Has to rejoin. Yes. So yesterday topic. Yes, these basics are complete already. These basics, all the basics completed. These basics completed. 1 second, just a minute. Yeah. See, low-level languages, high-level languages. Next about interpreter and compiler. So these topics discussed yesterday. Yes, about Java, Java introduction also discussed. Java introduction discussed. Okay. Java depends on both the compile as well interpreter. So up to this topic yesterday completed. Up to this topic yesterday completed. Yes, today topic is about Java features. Yes, Java features. Once again. Yes, your batch 7:30 p.m. Day 2. Yes, Java history. See, JDK 1.0 released with below features, right? These features. So these features. So these are, yes, JDK 1.0 features. JDK 1.0, yes, released with these features. Yes, to understand all these features, first we discussed about all the basics. All the basics were discussed. To understand that features, these basics were discussed. Now you can understand Java features very clearly. Now these features you can understand very clearly. Now let us see. First one, independent platform. Java is an independent platform. Okay. Yes, let us start with first one. Java is an independent platform. Java is an independent platform. Okay. Java is independent platform. Yes. Yes. So what does it mean? Let us see. Let us see about this one here. Yes. One second. See, Java is an independent platform. Yes, what does mean? Yes, what does it mean? What does it mean here? Java is independent platform. What does it mean here? Yes, here platform means ways. See, platform means it's a ways. It's a ways. See, previously we discussed in ways concepts. In ways, see here ways. See, operating system is a platform where we can run all the application software. Right? Ways, platform means here is a ways. On top of ways, all the programs running. On top of ways, all programs running. Right? It's a ways. On top of ways is right. Everything is running. Here, platform means ways. Platform means ways. Okay, platform means ways. So Java is independent of platform means Java program. Yes, Java program can run on any operating system. That's the meaning of independent. Okay. Yes, Java is an independent platform. What does it mean? Yes, platform means ways. Platform means ways. Okay, platform means ways. So that means Java program can run on any operating system. Java program can run on any operating system. That's okay, fine. Yes, now question is here. How Java made us independent platform, independent of platform. That is question. How Java made us independent platform? How Java made us independent platform? That is question. How Java made us independent platform? Yes, we should answer this question. Okay, Java is independent platform. That's okay, fine. Independent platform means Java program can run on any ways. Java program can run on any ways. That's okay, fine. How Java made us independent platform? Now we should discuss about this. Yes, how to answer this question? Yes, to answer this question, yes, you must have the knowledge of exe file and a dot plus file. About exe file and dot plus file. About exe file dot plus file. About exe file and dot plus file. See, first of all, about exe file. About exe file. Exe file. Okay. So what is exe file? See, what is an exe file? Exe means executable file. What is exe file? See, exe file is a binary code. Yes, that binary code today I'll show it. That binary code today I'll show you. Exe file is a binary code file. Binary code file. And it's a system understandable language. System understandable language. It's a system understandable language. It's a system understandable language. Okay. So what is an exe file? Exe file is a binary code file. Exe file is a binary code file, and it's a system understandable language. It's a system understandable language. So exactly what is exe file? Let us see. For example, here. For example, C program. Yes, C program exe file. C program exe file prepared. C program exe file prepared on Windows OS. C program exe file prepared on Windows OS. Okay. Yes. Can I run on Linux OS? Yes, it's a question for you guys. Yes, some question for you guys. Some question is C program exe file. Question is C program exe file prepared on Windows OS. Can I run on Linux OS? Anyone, can you answer this question? You guys?
No, sir, we can't.
Prepared on Linux, Windows OS. Can I run on other operating systems?
No, sir.
No, sir.
C program exe file prepared on Windows OS. Can I run on Linux OS? No. Answer is no. Answer is no. Why? Yes. Why? Reason is exe file is a OS dependent. Reason is exe file is a OS dependent. That's it. The reason exe file is a OS dependent. Now immediately question, why exe file is OS dependent? Why exe file is OS dependent? Immediately question here. Why exe file is OS dependent? Yes, how to answer? That is it. Why exe file is OS dependent? Yes, why exe file is OS dependent? To answer this, you must have the exe file knowledge. Yes, about exe file. Let us see about exe file. About exe file. This suppose for example here C program exe file prepared on Windows OS. Okay, for example here, yes, C program exe file prepared on Windows OS. Yes, it contains what? It contains what does it contain here? For example, C program exe file prepared on Windows OS. C program exe file prepared on Windows OS. Then it contains binary code for C program. Binary code for C program plus binary codes for yes C library. Binary code for C library. Plus binary code for OS library. Yes, what is it? I'll explain. See binary code for C program, binary code for C library, binary code for OS library. Yes, let me show that practically. Yes. C program. Open C once again. Yesterday. Yes. Yesterday we discussed about this program. So this is C program. Compile. Access. One second. Now this is C program. One second. So this is C program. Test.cpp. Okay. Yes, now backend of this is test.cpp. CPP means C++. C language both are same. C++ compile using for C as well C++ also. C as well C++. The C++ compiler. C drive, a TC turbo here installed here. Bin folder here. The test.cpp file here. Test.cpp. Test. See, this is one the related file. Let me delete it. So this is delete. So this is delete. Not test.cpp. So these are file. Test.cpp. File saved. Just now saved here. See. Yes, test.cpp. See 7:55 p.m. 14:10. Today 14:10, right? 14 just now saved. 7:55 p.m. Now let us compile. Compiles. When compiled, see this. Some test object file created. See properties. Yes, extension .obj. OBJ file means object file. So what is this test.obj file? What is this object file? It contains binary code for our C program. See here, this is binary code. This is your code, source code. This whole code converts into binary format and writing to test.obj file. That whole code, this complete C program code converts into binary format and writing to that object file. So this object file contains binary code for our C program. Binary code for C program. See C program exe. Yes, binary code for C program. Binary code for C program. This is in object file. The test.object file. Okay. Next. See in this program. Yes, some library files are included. stdio data, squanio data. Some library files are included. C library. stdio data, squanio data. These libraries added, right? Okay. See, these libraries also having its own binary code. These libraries also having its own binary code. These libraries also having binary code. Okay. So this is C software library. That library also having binary codes. Okay, fine. Now run. When you run this here, run it here. Yes, run it. See, observe backend. See here. That's the application that exe file created. Exe file. .exe file created. Test.exe. Here, this test.exe file contains what? See, C compiler taking binary code for C program, test.object file, binary code for C program. Next, binary code for a C library. So binary code for C library. Okay, binary code for C library plus binary code for OS library. Yes, OS library, OS, in OS is a library. See this OS library. See here, this is library, right? In OS there is a library. There is a library. In OS there is a library. Okay, so C compiler taking, yes, that C compiler simply taking binary code for C program, binary code for C library. Next, binary code for OS library. Now it's a Windows OS. Windows OS, so it will take Windows OS library. Okay, by linking all of this in generating that exe file, that is exe file Windows based. So that is Windows based exe file. Okay, C program exe file prepared on Windows OS. Then it contains binary code for C program, binary code for C library, binary code for Windows OS library. Okay, fine. Let us take one more example. Yes. C program exe file prepared on Linux OS. Now Linux OS. Let us say about Linux OS. What happens here? Linux OS. Let us start Linux OS also. Linux OS. See, Linux you can see practically. Okay, see here. See, Turbo C, yes, backend comparison, next to creation of exe file, everything is happening automatically. But in Linux, manually you have to do this. Linux, either Linux, I'm starting Linux base, Linux Ubuntu Linux starting, a Linux C program now. Yes. Yes, C program exe file prepared on Linux base, then it contains binary code for C program, binary code for C program same, binary code for C library, and binary code for Linux OS library. Linux OS, binary code for Linux OS library, binary code for Linux library. By linking all of this in generates exe file. Okay, let me show that practically. In my login, that Linux login. Linux login. See Linux OS. Yes, opening kernel. Yes. PWD, present working directory. LS means list of files and directories. Here mn is a directory. CD change of directory to mn. CD mn changed. Present working directory mn ls list of files. Okay. Yes, present working directory mn directory in this, these are files. Yes, see, you guys don't think about Linux commands. Our topic is not about Linux commands. Our topic is not a Linux commands. Our topic is about, yes, how C program exe file creating. Our topic is about exe file. One second, let me remove that existing files. Yes, ls test.c gedit. It's a Linux notepad. Gedit test.c gedit test.c. So much. See, a equal to 10, b equal to same program here also. Addition, subtraction, and multiplication. Okay. Yes, save and close. Now, so test dots. This should be compiled cc-c comparison cc-c test.c compiling compiled no error. Let's see this. Yes, here also test.o file generated. Test.dot means object file. This object file contains that object file test.o. That object file contains binary code of your C program with this part. Okay, this part converts into that object file. Next, std address is a predefined library. That is predefined. Std address, it's a predefined. That is predefined. That stdio.h is also having its own binary code. Okay. Yeah, that also having its own binary code. This file also having its own binary code. Now this C program code converts into binary code and writing to that object file. Okay, that test.o. That object file contains binary code for your C program. Okay. Now you should create exe file. cc-o. Yes, exe name is project exe. Any name that you can project exe test dot. Okay. See here -c means only compilation. CC means C language compiler. CC means C language compiler. -c means only compile option, only compiled. So test.o file object file generated. Yes, -o means object file, linking object files. It's a -o option is o means object files. O means object files. Object files linking. Okay, so this is C program test.c. C program compilation. This is object file linking. Okay, enter key. Yes, see this. ls. See that project exe file generated. Project exe file generated. Now running that exe file. See that addition, subtraction, multiplication. Okay, that exe file creating. Yes, that exe file. Yes, not in project. This name can be anyone. Suppose Durga. I am using name. Yes. Created by name of Durga, that exe file created. Running the Durga exe file. Yes, Durga, that exe name is Durga. You can write any name, no issue. Okay, right? Yes. Now what happens here? At the time of creating exe file, yes, C program, sorry, C compiler taking binary code for your C program. C compiler taking binary code of your C program. Binary code for C library. Binary code for Linux based library. Okay. Yes, here it's like this. Yes, C program exe file prepared and Linux based, then it contains binary code for C program. Next, binary code for C library, binary code for Linux based library. By linking all of this, it generates exe file. Okay, generates exe file. Now here, that project exe file. Here, project exe file contains binary code for C program, binary code for C library, and binary code for Linux based library. Yes, let me show that clearly. Yes, gedit project exe. Just I'm opening that exe file. Gedit, it's a notepad. On notepad, I'm opening the project exe file. Project exe file, it's opening. Just 1 minute, keep it time. Yes, see that exe file binary format. Special language. It's a system understandable language. Exe file format. Exe file format is a system understandable language. It's a binary code. This is exe file, right? Yes, next one more thing. Linux is a file command to check the type of the file. Linux is a file command to check the type of the file. File test.c. I'm checking test.c. Test.c is C source ASCII text. What is test.c? Test.c is a C source code. ASCII text. It's ASCII text. It's ASCII text. 1 second. Just a minute. Yes. So file test.c file. So what is test.c? It's a C source ASCII text. Now this file command, I'm checking project file. The project. Yes, see that. What is project? It's a executable file. That project is a executable file. Okay. Yes, in that executable file here is a ld-linux x8664.so2. See .so is an extension for OS library. .so is an extension. .so is an extension for OS library. Linux OS library. .so is a OS library. That means that project exe file, that project executable file contains Linux OS library. That's it. Very clear. Very clear. Okay. that exe file, that project exe file contains what? Linux based library. It's very clear. Linux based library. Linux based library. Right? Okay. Yes. I think now it's clear. Okay. So you can C program exe file prepared on Linux based, then it contains binary code for C program, binary code for C library, binary code for Linux based library. Let us take one more example. One more example. One more example. Yes. Let us take C++. C++ program exe file. C++ program exe file prepared on Windows base. Windows base. Windows base. Then it contains binary code for C++ program. Next, binary code for C++ library and binary code for yes Windows OS. Binary code for yes Windows OS library. That's it. Okay. Now what is happening here? Every time of creating exe file, OS may be anyone, Windows OS, Linux OS. Okay, that always see always that exe file yes exe file is linking with OS library. Yes, exe file is linking with OS library. OS library is in all the cases. See, yes, C program exe file or Windows OS, C program exe and Linux OS, or C++ exe file or Windows OS. Any case, all the cases, common thing is what? OS library. Okay, so all the cases OS library linking here. Yes, always exe file linking with OS library. So always exe file linking with OS library. Okay. Yes, it is called static linking. Statical linking. Okay. See here. So exe file. Yes, links with exe file. Links with OS library. At the time of generating exe file. Yes, it is called as statical linking. It is called as statically. Yes. Statically, it is called as statically linking. Okay, so what is statical linking? I will explain, just wait. Yes, so once dynamically linking explain, you can understand statical linking. Dynamically linking, once we discussed dynamical linking, you can understand statical linking also. Okay, so exe file linking with OS library at the time of generating exe file. Yes, it is called as statical linking. Okay, yes, now so for example, test.exe file prepared on Windows base. Prepared on Windows base. Prepared on yes Windows. Prepared on Windows base. Then it contains yes Windows OS library here. Yes, test.exe file prepared on Windows base. Then it contains Windows OS library. Right? Okay. Yes. Now test.exe file with yes Win library on different platforms. Library working on different platforms or ways. Different platforms. How it's working? Let us see here. Different platforms. The different operating systems. How it's working here? Different platforms. Okay, different platforms. Yes, how it's working on different platforms. Let us see. Test.exe file with Win library working on different platforms. How it's working on different platforms. Let us see. Let us take different platforms here. Different platforms. So first, let us take Windows platform. Okay. See, computer, hardware. See, hardware. Yes, on top of hardware. Yes, OS running Windows OS. On top of hardware. Yes, Windows OS. Windows OS with Win library. Windows OS with Win library. Okay, on top of which now running your C program. Test.exe file. Yes, on top of it running test.exe file. Yes, hardware on top of it now Windows platform. On this platform, when you try to run test.exe file, what happens here? See here, test.exe file with Win library working on different platforms. Test.exe file already linked with Windows OS library. So when you try to run test.exe file, yes, it will try to call Win library. Okay, yes. See, here since test.exe file with Windows OS library, since linked with Windows OS library, it will try to call to Windows OS library here. Okay, since test.exe file linked with Windows OS library, since already linked with Windows OS library, yes, when you try to run it, yes, it will try to call Windows OS library. Yes, here available. Yes, calling Windows OS library, using that library communicates with hardware components. So that program completing successfully completing. Okay, suppose same exe file running on another platform, suppose Linux base. Let us take Linux base. Linux platform. Yes, Linux base with the Linux library. How it's working? Okay. Now same test.exe file, when you try to run a Linux base here, and Linux OS also it will try to call to Windows OS library, because already exe file linked with OS library, that link is fixed. Yes, that link is fixed. On Linux OS also it will try to call to Windows OS library. But here is not available, simply fails. Okay, here library available, then calling Windows library, then communicate with the hardware components. So successfully executing this case here. Same exe file, when you try to run a Linux base here, yes, library is not matching. That exe file already linked with Windows OS library. It will try to call Windows OS library, but here is not available, simply fails. Okay, that link fixed. See, test.exe file with Windows OS library. Okay, yes, that link is fixed. It means statical linking. Static link is fixed. Okay, yes, Windows OS library already instead of test.exe. When you try to run test.exe file, it will try to call Windows library. Here it's available, successfully executing. When you come to on this OS, it's not available. Simply fails, right? Let us take another platform. Suppose Mac platform, Mac OS. Let us take Mac OS with Mac library. Then what happens? Yes, here also it will try to call Windows OS library, but it's not available. Here also not available. So fails here. That's it here. So that's the reason exe file is OS dependent. Exe file is OS dependency. Since exe file statically is fixed. That link is fixed. Since exe file statically linked with OS library. Since exe file statically linked with OS library, yes, it is a OS dependent. Here OS dependent. That's it. Okay. Now see why exe file is OS dependent. Simple answer. It contains OS library. That's it. It contains OS library. Yes. Since exe file contains OS library, is OS dependent. Why exe file is OS dependent? Reason, it contains OS library. That's it. So this is about exe file. Okay. So exe file. Yes, exe file is a binary code file. The system understandable language. It's a OS dependent. Yes, reason, it contains OS library. So it's about exe file. Okay, right? Yes, now let us come to Java. Yes, let us start Java. Let us see Java. Java.class. About Java, dot class file. About Java dot class file. Okay. Yes. See. Yes. Let us take same examples. 1 second. Let us take same examples. The C program example in Java. Same example in Java. Yes. Same example in Java. See Java program. Java program not exe equals dot class file. Java dot class file. Java program dot class file prepared an interface. Then it contains binary code for Java program. No, it's not a binary code, it's a byte code. Byte code. Byte code for Java program. Byte code for Java program. Okay. Next byte code. Yes, byte code for Java library. Byte code for Java library. Byte code for Java library. Okay. Next, see byte code for Java program. Byte code for Java library. Next what? Binary code for OS library. No, this part don't. This part don't have. This part don't have. See, byte code for your Java program. Byte code for your Java program. Okay. Next, byte code for Java library. See, Java library also developed in Java. Java library also developed in Java. See here. C library developed in C language. C++ library developed in C++. Python library developed in Python. Like that here. Java library. Java library developed in Java language only here. Java library developed in Java only here. Java library developed in Java. So Java library developed in Java. Okay, that means here Java dot class file. Java program dot class file contains what? Byte code for your Java program. Byte code for Java library. So Java library also developed in Java. That means here, yes, it's a pure Java code. Okay, so it's a dot class file. Yes, dot class file. Dot class file. Dot class file is a pure Java code. Pure Java code in byte format. In byte format. Pure Java code in byte format. In byte format. Pure Java code in byte format. In byte format. Okay. Yes, it don't have any. It don't have any OS library. Yes, it don't have any OS library. Any OS library. Any OS library. Okay. So dot class here, dot class file. See, dot class file is free from OS library. Dot class file is free from OS library. Okay, dot class file is free from OS library here. Don't have any OS library. Okay, don't have any OS library. Suppose tested dot class file. Tested dot class file prepared on any OS. Prepared on any OS. Anyways, yes, it don't have any OS library. Don't have any OS library. Okay. Now this tested dot class file. So tested dot class file is working on different platforms. Tested dot class file working on different platforms. How tested dot class file working on different platforms? Let us take different platforms here. Like a C program, tested dot class file, tested dot class file working on different platforms. Yes, let us take different platforms here. First, Windows platform. Yes, Windows platform. Okay. Yes, now tested dot class file. So tested dot class file. One second. Hello. I'm deeply in phone just for the classroom. Just just. See tested dot class file. See here tested dot class file running on this space. See, can I run it directly? This tested dot class file, can I run on Windows space directly here? See, 1 second. Previously, we discussed in OS concepts. See, every program has to link with OS library before going to run. Every program has to link with OS library, otherwise cannot run. So while linking, it has to communicate with the hardware component. These programs linking with OS library of linking then communicates with the hardware component. It has to link. Okay, every program has to link with OS library. It has to link with OS library. Otherwise cannot work. Otherwise cannot run here. Okay, now test dot class file. So test dot class file. See, dot class file is free from OS library. Dot class file is free from OS library. So dot class file don't have any OS library. Dot class file don't have any OS library. Then how it can run? It can't run directly here. So now this tested dot class file has to link with OS library compulsory. The tested dot class file also has to link with OS library. It's not linked, so cannot run, but it has to link. This tested dot class file has to link with OS library here. Okay, who will link it? For linking purpose, yes, between tested dot class file, Windows OS, one more layer come to picture. One more layer come to picture. Yes, what is that layer? Yes, anyone idea? Anyone can you guess it? Not idea. Anyone guess it? Try to guess it. Yes, between tested dot class and Windows OS library, one more layer come to picture. One more layer will be coming to picture. So one more layer. What is that layer? Anyone can you guess it? Anyone can you guess it? Anyone can you guess it? Anyone can you guess it?
Interpreter.
JVM, Java Virtual Machine. Java JVM stands for Java Virtual Machine. JVM separate topic. There is one day topic, one class separately. JVM architecture is there. Okay. Yes, JVM. JVM come to picture. Now JVM. See, JVM taking tested dot class file. JVM taking tested dot class file. Linking with Windows OS library. Once linked, it communicates with the hardware component. That's it here. Okay. Yes, let us take another platform. Another platform. Let us take another platform. Linux base. Linux base. Linux base with the Linux library. Linux base with Linux library. Now here also same thing happens. On Linux base also there is JVM. That Linux JVM taking test dot class file links with the Linux base library of linking communicates with hardware components. That's it here. Okay. Next, let us take another platform here, Mac OS. On Mac OS also there is a JVM. On Mac OS also there is JVM. Okay, now Mac JVM taking tested dot class file and linking with Mac OS. Mac OS. Okay, suppose one more platform. Suppose Unix OS. Unix OS. Unix OS. Unix OS with Unix library. On Unix OS also there is JVM. Unix OS also having JVM. Yes, Unix JVM. Simply Unix JVM taking tested dot class file links with Unix OS library. Now what is happening here? See, every time of changing ways that link changing, right? See, when tested dot class file running on Windows OS linking to Windows OS library. Same tested dot class file if it is running on Linux OS linking to Linux OS library. Same tested dot class file if it is running on Mac OS linking to Mac OS library. Next, if it is running on Unix OS, yes, linking with Unix library. That means same tested dot class file. So every time of changing ways that link changes. This is called dynamical linking. Dynamically is at runtime. At runtime link changes. So runtime, yes, if running on Windows OS links to Windows OS library. Same dot class for running on Linux OS links to Linux OS library. Same dot class for running on Mac OS linking to Mac library. So that link is changing, right? Link is changing. So it's called dynamical linking. Dynamical linking, right? Okay. Yes, since Java dot class file dynamically is linking with OS library by the JVM. Yes, it's an independent platform. Independent. Yes, independent platform. That's here. Independent platform, right? See, In case of exe file, what happens here? See exe file. See that, let us back to exe file here. Exe file. See exe file links with OS library at the time of generating exe file itself, right? That link is fixed, never changes. Okay. Yes. Exe file prepared in Windows OS, then it contains Windows OS library. That means that exe file linked with Windows OS library, that link is fixed, never changes. That link never changes. Never changes. That is static link. Static means fixed. Statically linking. Statically linking. Statically linking. That link never changes. Fixed. That link is a fixed. Yes. Exe file with Windows OS library, it's a fixed. That won't change that link here. That link never changes. That link never changes. Since exe file statically linking with OS library, it's a OS dependent. Okay. Statically linking. Statically linking means that is OS dependent. Okay. Statically linking. Yes, any program. Static, yes, wherever exe file concept comes is a statically linking. Statically linking. Statically linking. Yes, is a OS dependent. OS dependent. Statically linking is a OS dependent here. Okay. Dynamical linking. Dynamical linking. Yes, Java dot class for dynamical linking with OS library. Dynamical linking is a independent of OS. Independent. Yes, independent of OS. Independent of OS. Independent of OS. Independent of OS. That's here. Okay. See. Java and Python. Java and Python. Yes. Java and Python dynamically linking with OS library. Java and Python dynamically linking. So these are independent platforms. Java and Python. Python script also dynamically linking with OS library. So every time of changing OS, that link changes. In Python also happens same thing. So those are called as independent platform. That is independent platform. Okay. Since Java program dynamically linking, it's a independent platform. Yes, exe file statically linking, OS dependent. Okay. See, anywhere statically linking comes means otherwise OS dependent here. Dynamical linking means independent of OS. That's it. So how Java made us independent platform? I think clear. This is clear, right? Okay. Yes, JVM takes care of that linking here. Yes, if Java program running on Windows OS, Windows JVM, Linux OS, Linux JVM, Mac OS, Mac JVM, Unix OS, Unix JVM. Now here's some doubt too. See, Windows JVM, Linux JVM, Mac JVM, Unix JVM. So I'm talking about different JVMs. Then is it part of OS? JVM, is it part of OS? Yes, about JVM. JVM, is it part of OS? No, JVM is not a part of OS. JVM is not a part of OS. Yes, it is from JDK. It is from JDK software. It is from JDK. Yes, JVM is from JDK. JDK from software, JDK software. JVM is not a part of OS. It is from JDK software. Then how to get JVM here? Yes, to get JVM. So to get JVM on OS, yes, we should install. Yes, we should install. Yes, we should install JDK. Yes, we should install JDK. That's it here. Yes, to get JVM on OS, we should install JDK. Once JDK install, getting JVM automatically. Yes, that JVM is responsible to make Java as independent platform. Yes, JVM. Since JVM links. Yes, since JVM linking dot class file with OS library is independent platform. Next, one more important point here. See, Java dot class file. Java dot class file is an independent of OS. Independent of OS, right? Independent of OS. But JVM is a OS dependent. 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 Yes. See, yes, interesting point, right? See, Java dot class. Your Java program is independent of platform, independent of OS, but JVM is OS dependent. JVM is OS dependent. That means Windows is having its own JVM, Linux is having its own JVM. Okay, Mac is having its own JVM, Unix having its own JVM. See, Sunsoft developed different JVMs from different applications. Okay. Yes, by is dependent reason JVM developed JVM developed in C++. Yes, if developed in C++, it's exe file concept, right? Now again, exe file concept come to picture. It's exe file. So JVM is a JVM is C++ exe file. C++ exe file. So that's the reason why it's dependent. JVM is a exe, C++ exe file. Okay. Sunsoft has developed yes, developed JVM for every waste in the market, every waste in the market means yes, JVM for Windows OS, JVM for Linux based, JVM for Unix based, JVM for Mac based, JVM for Solaris. Like different JVMs are developed for different applications. See, since JVM is a OS dependent, JVM is a OS dependent. JDK also OS dependent. JDK also OS dependent. That is since JVM is OS dependent, JDK also OS dependent. See, that means see this. Suppose Windows JVM. So that JDK must have Windows JVM, right? Suppose Linux based Linux JVM. For Linux JVM, that Linux JDK must have Linux JVM. The reason JDK changes. Windows JDK different, Linux JDK different, Mac JDK different. So depends on ways that JDK changes. See, in my system, yes, Windows JDK available. Now the JDK I can install only on Windows base. I can't install on Linux base. Yes, it's a Windows based JDK. Windows JDK only on Windows base. I can't install on Linux base here. See, let us go to the site here, Oracle site here. Sorry. Downloads JDK. See downloads. See this Java. See this. These are all the JDK downloads. 8 downloads. 8. See, this is Linux JDK. Up to this is Linux JDK. Linux JDK. Next, this is Mac JDK. Mac JDK. Next, this is Solaris JDK. Solaris JDK. Next, this is Windows JDK. Windows JDK, right? So different applications are having different JDKs. Okay. Yes. Suppose installing on Windows OS, you have to download this JDK here. Suppose Mac OS means you have to download this one here. Okay. You guys don't worry about JDK software. I will provide. It's available in your Google Drive. I share it to your Google Drive. From the Google Drive, you can download it. From the Google Drive, you can download the topic tomorrow. Tomorrow we'll discuss how to download JDK. Next, how to download Eclipse, how to set up and all this. Tomorrow we'll discuss. Tomorrow we're going for Java setup, Java installation. Okay, next JDK installation, Eclipse installation, and developing first application. Tomorrow topic. So this is about independent platform. That's it. Now, exe file dot class file. What's the difference? See, dot class file, exe file. What's the difference? See this. Exe file and dot class file. Exe file and dot class file. See, exe file and dot class file. The differences. Exe file is a binary code file, right? Exe file is a binary code file. Dot class a byte code file. Binary code file, byte code file. Yes, exe file is binary code file. Dot class byte code file. Exe is system understandable. Dot class is JVM understandable, right? See, exe file contains what? OS library. Here they say OS library. Dot class file don't have any OS library. Yes, is a pure Java program byte format. Yet don't have any OS library. Yes, it contains byte code for Java program, byte code for Java library. That's it here. Don't have OS library. Okay. See, exe file is prepared for specific OS. Yes, exe file is already prepared for specific OS here. exe file for Windows OS, exe file Linux OS like this. So OS library statical linking with exe file. OS library statical linking. See, dot class file is not a prepared file. It don't have any OS library. See, OS library dynamically linking with dot class file at runtime here. Okay, so exe file, it's a binary code file and it contains OS library. Exe file is a binary code file. Dot class file is a byte code file. Yes, exe file links with OS library, but dot class file don't have OS library. Next, exe file statical linking. Dot class file is a dynamical linking. That's it here. So that's the difference. So exe and dot class file, simple difference. Exe file is a binary code, dot class a byte code. So this is right. But next important difference. Yes, it contains OS library and yes, this is with OS library. This is don't have any OS. That is next difference. Next difference statically and dynamically. There are main important difference. Next other difference also. So this is about exe file dot class file. Okay, so that's all about independent platform. I hope we understand, guys, how Java made us independent platform. Is it clear? How Java made us independent platform? That concept is clear, right? Yes, guys. This topic about exe file, why exe file is OS dependent. Okay, how dot class file made us independent platform. I hope we understand, guys. Is it clear?
Yes, sir.
It's clear, right? 1 second.
Yes,
I'll
sir.
tell you one thing. This topic, most of the time, simply they will explain, but they don't explain about exe file. How that linking with exe file practically explained, but no trainer will explain practically. Even Java also, how that linking very clearly explains. Yes, even in websites also. See, many websites are in worldwide. No website provide information like this. Okay, even no Java trainer, yes, will explain like this. Yes, to explain that, first of all, the trainer must have the embedded C knowledge, Linux knowledge, embedded C knowledge, and Java knowledge and everything. Otherwise, cannot explain. Yes, even I showed that library also. Yes, in Linux base, Linux base. That how that library linked. That link also practically should see that library LD-Linux. That is a library. Is embedded C concept actually. Embedded C concept. See, my beginning career, first 4 years embedded C, later changed to Java. So because of that reason only, I'm able to explain this one here. I'm sure no trainer will explain these concepts like this. Okay. Yes. So next coming class are the same thing like this. Very interesting every class. I'll make very interesting here. Even coding part also, everything make interesting here. Okay. I hope everyone you understand here. So that's all about yes, independent platform. So with that, all this Java basics finished here. Next, entering into Java programming. So for the Java installation, Eclipse installation, all this right. After finishing, we'll start program. Yes, tomorrow going for installation. Don't miss tomorrow topic. Tomorrow JDK installation and Eclipse. Tomorrow we'll discuss. Yeah, that's all for today.
So I have one doubt.
You tell me.
So you are saying that JVM is made by using C++ code.
Yeah.
Then how it is getting compatible with the Java compiler? So how it is working for the Java?
Yeah. See, behind of Java program, always C++ code will be running. Behind of Java program, when you're running Java program, JVM working. That JVM developed in C++. That C++ code will run. How that code is running? Yes, I'll show practically. Once started Java programming, in Java program, suppose from Java code is the behind of that, how JVM working. In JVM, how C++ code is working. With memory map, practically I'll explain. Yes, don't worry.
Okay,
Coding
thank you,
topic very clear. In coding, I'll show practically. Yes, topic is there. Actually, the topic also there. Okay, yeah. So
Okay,
that's all. That's all. So thank you guys. Yes, tomorrow Saturday
thank you,
also
sir.
taking to Saturday classes. Tomorrow Saturday also class. So tomorrow installation part. So thank you guys. Yes, see you tomorrow. See you tomorrow.